Welcome to Object Classification using Deep Learning on LiDAR Data. I'm Scott Campbell. I'm the CEO of Solve3D.
And I'm Brad Ashley. I'm the Director of Business Development here at Solve3D. And we're happy to have you here with us today. We're going to be going through our first of 3 videos on the topic of deep learning for LiDAR data. And today we're going to be focusing specifically on the data for training. Here's an example of what we're trying to accomplish through these 3 videos. We've got a video going that's showing the before classification data. This is a LiDAR data tile that wasn't classified. And now as we go through, we start to see that the data becomes classified, and you can see the various colors of that classification. This is actually a tile of data that we'll be using throughout the hands-on part of the training here, and you'll be getting the exact same results by the end.
Yeah, this tool is deep learning. It's artificial intelligence, deep learning. Why did we pick deep learning, Brad?
Deep learning gave us the ability to be adaptive and that we could teach our own examples. We didn't have to stick with the traditional ones that industry uses, and we can be more adaptive. Once it's taught, it becomes quite a lot faster than programmatic approaches. And we can often find strange characteristics or hidden characteristics that we wouldn't have seen otherwise.
Yeah, I guess if I think about it from the perspective of the users of this, they know the data. This is the business they're in, right? And they don't have to have teams of programmers. They just need data, which, is something I think we're going to talk about. So what about, what are things that people should look out for then?
Well, I think as you're going to see, even with this first video, the important piece here is getting the data ready for training. If you don't have a good model, if you don't have good data that's being used for the training, you're not going to end up with good results out of the trained model. So it does take time to get that data prepped and ensure that it works for the model you need. Also, if your data is inconsistent, whether you have characteristics that are hidden in the back end, you're going to have to start thinking about that and making sure that there's no bias in your data. And that's what we're going to spend most of the rest of this time in video 1 on.
Yeah, no, that's a really good point. In fact, I've got a little example I like to use about fire hydrants. Now, I know this is about images, Brad, and we're here to talk about LiDAR, but the principles are the same. And I think maybe the folks watching the video can relate really quickly to the pictures we're going to show as we flip through this. In the example, I like to talk about, imagine if you've got to go through and identify all the fire hydrants in Chicago. Some of the things you need to think about as you approach deep learning in this kind of task is, how many variations of fire hydrants are you? I mean, even if you hired a student to do this, you have to give them a book and say, these are all the different types of fire hydrants I want you to look for. If they're all the same, fantastic. If they're all the same shape, but you also got to take into account, how many different colors are there? Has the city just gone through a painting exercise where they're changing them from the traditional red to high-vis yellow or something like that, right? You also need to take a look through your data to see if there's areas where, the fire hydrant's blocked. I mean, Chicago gets snow. If you captured some of these pictures in the wintertime, is there snow? Or if you're going through maybe late August, late summer, is there grass blocking? Those are examples of images that are not going to be that great for deep learning training. It introduces a lot of noise, and it's really, really not good.
Yeah, those are some great examples of the issues with the actual physical object. But on top of that, you have the potential issues of bias that would come from multiple sensors, multiple collection methods. You can imagine with most survey firms, they're collecting mobile scanning, they're potentially collecting terrestrial scanning, and even using aerial photography or aerial LiDAR for these types of applications. And I think that, you have different types of optical distortion. You could have different types of perspectives, obviously from the ground versus from the sky. You may have different color banding between the different sets of data and even different bits of images between 8 and 16. Many survey firms like to collect their data at night because there's less traffic, there's less pedestrians. And so if some of the data has been collected in the daytime and has true RGB values, and then some of the data has been collected at night and is in black and white, you again are putting in differences between those data collections.
Yeah, I think those are really good points. And I think not that we want to scare people off, but what we're trying to get across is people just really need to have a look at the data that they want to use for training and consider whether it's representative or not. The other thing I think people need to think about is, what is their strategy for the model based on the data that they have? And I continue the example with, you're looking at doing Chicago, and as you're starting to plan Chicago, your client comes back and says, I want you to do the same thing in Paris, France. And so now you have to ask yourself, well, do they use the same hydrants? Because if they use the same hydrants, then you might be able to get away with a single model for both cities, as long as your training data is representative of both cities. But if they're different, if they're radically different, then you have to make a decision. Do you want to mix your training data from both cities and train a model that will recognize hydrants in both cities? So your strategy is one model, or separate them out and train a model, two separate models, one for Chicago and one for Paris. And of course, that's a business question, right? That can only be answered by the people who are actually doing the job. The big thing to take note of, I think, in all this is that usually, in most cases, you cannot go back and retrain the model. So if you train for Chicago and it's already done, well, you're done. You either need to retrain for both Chicago and Paris, or you just need to retrain for just Paris.
Those are all good points, Scott. And I know that we've been focusing here on some image examples, but the same thing can be used for LiDAR. Whether you're using terrestrial, aerial, mobile LiDAR collection, you're going to get different biases, different perspectives, and obviously different point cloud densities and intensity values. Having good training data is the only way to ensure that you got a good trained model. If the old adage, garbage in, garbage out, is the exact same in this case. If you put garbage data in, or data that's not well classified, not well segmented, you are going to see the same problems in the future data collections when you go and run them against the classifications. So although we're spending time here talking about the importance of the training data, it is really one of the most critical pieces to this whole workflow.
Yeah, in fact, that's a good sum up point, I think, Brad. The advantage of deep learning is the fact that you don't need a team of programmers to try to figure out how to identify objects, but you need good data. And, if you're not going to spend the time getting good training data, then this is definitely not the right tool for you. So what's next in the sequence?
Our next video 2, will be talking more about how we go about training that data, getting the data prepped and ready to run through the training algorithms in preparation for the final video, which will cover classifications. One thing to note, the data that you're going to be receiving to use in the workshop is already pre-processed to align with the things that Scott and I have talked about here today. So you don't have to worry about the time that you're going to take to process those files to get them ready for this training. That's already done.
Yeah, that's it. So let's move on to the next step.
Great. Thanks, Scott.
Thanks, Brad.